Okay, so this set of instructions will go over some IV dosage calculations, which again we will discuss in lab number 2, but this will just be a brief introduction to the methods. So the IV methods of calculations, there's actually multiple for each different kind, but I'm going to show you how to take a derivative of the desire over half times vehicle in order to make this work for each one of these types. So this is the common ones that you'll see, but I'm going to show you. Okay, so first example is going to be this one. So our order is to infuse 500 milliliters over 2 hours. Pharmacy sends us a bag of 500 milliliters. What will be the infusion rate in milliliters per hour? So pharmacy sends us a bag of 500 milliliters. That's exactly what we needed, so this is not really needed. So crossing out information that I don't need. It will distract me. Now, our order is to infuse 500 milliliters over 2 hours. And we need to get it to how many milliliters in 1 hour. So we're going to divide by 2 in order to do that. So, or you can do your cross-dimensional, however you want to do it. So 2 hours to get to 1 hour is to divide by 2. So 500 divided by 2 equals 250 milliliters per hour. Note that the units are not going to cross out when you do this. When you cross multiply, they're not going to be on opposite sides. So they are going to stay. They're going to remain there. Okay, so our rate is going to be 250 milliliters per hour. So it's going to take 2 hours. Of course, it says that in order to do it. So then worked it backwards, so it works. So our next example is going to be this one. The order is to infuse 20 milliliters per hour, but we have a liter that on hand from the pharmacy. How long will it take for this to completely infuse? So if we have a liter, it's equal to 1,000 milliliters, and we need that 1,000 milliliters to infuse at 20 milliliters per hour. So we're going to 1,000 divided by 20 times 1 hour is going to be, what was it, 50. And our milliliters are going to cross out. Go away. I don't know why my N won't go away. And there we go. 50 hours. Okay. So you can see how that was kind of like a desire. This is kind of like a have. This is kind of like a vehicle. Kind of set up the same way. Desire over half times vehicle. Okay, next is going to be a drop factor question. So we're going to take 500 milliliters. This is supposed to be infused over 2 hours, but we need to use a drop factor tubing. And that tubing is going to be set for 15 drops per milliliter. How many drops per minute rate will this need to be infused at when we set the pump? So our volume is 500 milliliters, and our have is going to be our time, but our time here needs to be in minutes. So 2 hours in minutes is 120 minutes. Okay, times our drop factor, which is 15 drops. I'm gonna, instead of putting it beside it, I'm gonna put it like this so that I don't get confused and my milliliters cross out. So then 500 divided by 120 times 15 equals 62.5, and I still have drops and minutes on the bottom, which is what my problem asked for. So 62.5 drops per minute is the rate that I'm going to infuse it at. So here my vehicle is my drop factor, My desire is my volume, and my have is my time frame. Very similar to the desire have over vehicle. Again, we'll discuss these in lab. You also have your workbooks to bring to class, and we will practice different versions of these problems in formulas in lab together. If you have any questions, you can email me or bring it to your next lab day. Thank you.